All right, part 2 of the video. I had to go check on my daughter and say congratulations for losing your tooth, which she honestly did while I was making this video, or the last video, sorry. So remember we were talking about how the equation 2x plus 3y equals 12 and how that equation can have an infinite amount of possible solutions. And I looked at the graph and we kind of talked about that. So if I give you 2x plus 3y equals 12 and I give you another equation of y equals 2x minus 1, now that changes things. Both of these equations are graphed together. So if you're given both these equations, so if I give you both of these, if given both of these, a single solution can be found. Over the next week and a half, I'm going to show you 3 different methods to find that single solution. Today we're going to do graphing, and then in the coming days we'll do substitution and then elimination. By graphing, an intersection point can be found for the 2 lines and this point represents a solution. Alright, so let me show you what I mean. I'm just going to take 1 second and I'll graph my line again. Don't need that drawing anymore. So, if I take my line and I believe I had 2x plus 3y equals 12, and there's my graph. If I now graph our second line that I had said y equals 2x minus 1, you can see now with our graph, I can zoom out a little bit, you can see both lines extend outwards towards infinity. But as I zoomed in, you can see there is a point of intersection for these 2 lines. And that point of intersection would represent a solution for these 2 lines. So that point of intersection for the 2 lines that I've highlighted here, the 1.875 and 2.75 would represent a solution for these 2 linear equations. The red line being this equation, and the blue line being or representing this equation. So what we're going to do now is we're going to work at trying to show you or help you be able to find and determine if lines intersect and how to verify information like that. Here we go. So for my first example, I'm going to determine if the point of intersection of 2 lines is through a given point. So example 1, and I'm going to do 2 examples like this. So example 1, determine if the given point is at the intersection point, at the intersection of the 2 lines with the given equations. So, for example, for A, I'm going to give you 2 equations. Y equals 2x plus 3 and y equals negative x. And then the point of intersection that you are going to verify to see if this is where the 2 lines cross is going to be negative 1, comma 1. So we are going to use math to verify. We're not going to graph them to start. We're just going to take these two lines and I'm going to see if there's a way to verify that this is actually the point of intersection. So give me 1 second. Are you ready? If you want to pause me right now because you're still writing, that's fine. I'm just going to flip to my next slide. So to start, in A, I said y equals 2x plus 3 and x, y equals negative x, and the point was, or the point of intersection we were going to test is negative 1 comma 1. So to start, what you're going to do is we're going to substitute one of our values. So let's substitute. And let's substitute in our x value of negative 1. So we're going to say substitute x equals negative 1. If you're like, where did he get negative 1 from? I'm so lost. I'm pulling it from my point that I'm given right over here. So that's where I'm pulling negative 1 from. I can pick one of my equations, so I'm just going to substitute into this equation to start. So I write y equals 2, bracket, I substitute in negative 1. Once I've substituted in negative 1 plus 3, the next step I do is I now multiply. What's negative 1 times 2? It's negative 2 plus 3. Finally, what's negative 2 plus 3? It equals 1. So let's go back and look for a second. Does y equal 1? Yes, y equals 1. So that's a good sign. So this does satisfy when x is set as 1 and substituted in, it does satisfy this equation. So we can say, since when x equals negative 1, y equals 1, negative 1, 1 is a possible solution. Perfect. So that's our first possible solution. I'm just going to sketch off this area because I think I can squeeze in and I'll do my summation on a new slide. So our next example is y equals negative x, my second equation. So I'm going to do the exact same thing I did before. I'm going to substitute in my point. So I go y equals negative, open bracket, and when you substitute in, use brackets. My value for x is negative 1, close bracket. And I hope you see what I did there. The negative comes from right there. My value for x is negative 1, so that came from right there. What's a negative times a negative? It's a positive, so y equals 1. So because it also satisfied, or because it also, y does also equal 1 on this point also satisfies this equation, and that means that these two lines intersect at negative 1, 1. So we have verified it. So you need to write a final statement. I've just run out of room. And I would say something like, since negative 1 comma 1 is true for both, it's not e on both equations, it is the intersection point for these two, for the two linear equations. Perfect. All right. I'll do one more example. All right. So let's do B. Same idea. We're going to determine if the given point is the intersection point. So I've got y equals negative 2x, and my second equation is 3x plus 2y equals 4, and our point is 2 comma negative 4. So the first thing I'm going to do is I'm going to substitute x equals 2. Where on earth did he get that from? Right here. Don't forget that's an ordered pair of x. Yikes, that doesn't look like an x at all. X comma y. And the first value is 2 for x, and that's what x equals. So I'm going to substitute that in. Here we go. Try to work over here. So y equals negative 2x, y equals negative 2 bracket 2. What's 2 times negative 2? Oh, negative 4. So far, therefore, 2 comma negative 4 satisfies y equals negative 2x. So make a little bit of room for myself. The next one I'm going to try is 3x plus 2y equals 4. So because this takes a little bit of a different form than past ones, and because we have 4 on the side by itself, what I'm going to do is I'm going to substitute x and y into my equation for x and y, and I'm going to see if they equal 4. Alright, so next thing I'm going to do is I'll go 3 times 2 plus 2 times negative 4 and see if that equals 4. Right? What's 3 times 2 equals? 6 plus what's 2 times negative 4 equals? Negative 8 equals 4. What's 6 plus negative 8? It's negative 2 equals 4. Does negative 2 equal 4? No, they do not. They are not equal. So therefore, 2 comma negative 4 does not satisfy 3x plus 2y equals 4 and is not the intersection point. I've run out of room. The intersection point, and that's what I'd write down there, would be is not the intersection point. I'm going to stop there, and hopefully this has been helpful for you to do the first part of your homework. On Friday, what you're going to be looking at is how to actually solve it using graphing. I thought I'd do the algebra method today and show you some of the algebra, and tomorrow you can do the graphing. I hope this is helpful. Take care.